Hello my dear students, in this lecture we are going to see Galilean transformation equation. Now in previous lecture, which was the first lecture on relativity topic, we have seen what is the concept of relativity, right? And again we have seen the special relativity theory as well as general relativity theory, and as well as we have learned frame of reference. Now my dear students, to understand this Galilean transformation equations, we need to understand frame of reference, and I hope you already seen my previous lecture. So in 1 minute I will recall this frame of reference. Now my dear students, let us write frame of reference. Now in previous lecture we have seen there are basically two types of frame of reference, that is inertial frame and non-inertial frame. First is inertial frame and other is non-inertial frame of reference. Right, these are the two frame of reference. Now inertial frame of reference means it is non-accelerated. Inertial frame means non-accelerated, means here acceleration is zero, that is acceleration is zero, and as per Newton's second law, force is equal to mass into acceleration. As acceleration is zero, there is no force, and whenever acceleration is zero, there is no change in velocity. So acceleration is nothing but change in velocity divided by time, means there is no change in velocity. Velocity change is zero, means velocity is constant. Here for inertial frame, velocity is constant, right? And my dear students, the exactly opposite will be for the non-inertial frame, means it is a accelerated motion. Non-inertial means it is a accelerated motion. Accelerated motion means acceleration is not equal to zero, therefore force is equal to mass into acceleration. As acceleration is not zero, mass is never zero, this is also not equal to zero. There is unbalanced force present, and as acceleration present, therefore this acceleration, which is nothing but change in velocity with respect to time, and this acceleration is not equal to zero, it is an accelerated motion. That means the velocity change is not equal to zero, means velocity changes. That means velocity changes, right? And my dear students, here in case of Galilean transformation equation, the frame of reference is always inertial frame, right? The frame of reference will be always inertial frame, means my dear students, here in case of Galilean transformation equation, the velocity is always constant. Velocity is always constant, that you have to understand. Now let us understand this Galilean transformation equation. Now my dear students, this Galilean transformation equation is valid only for the low velocity particles. It is not valid for the very high velocity particle. Now whether the velocity is high or low, this comparison is done with the help of velocity of light. Now we know that c is represented as velocity of light. C is velocity of light in vacuum. Velocity of light in vacuum, the medium is vacuum. Now my dear students, I think you must know this value. This c is nothing but 3 into 10 to the power 8. It is meter per second, which is very high. This velocity is very high, right? And my dear students, our velocity, this v is nothing but velocity of frame of reference or velocity of any frame, velocity of frame, right? And my dear students, here this Galilean transformation equation is valid only for low velocity particles, means this velocity of frame is very less than velocity of light, right? Velocity of light is very much high as compared to velocity of light. This velocity we can say negligible, right? For such condition only Galilean transformation equation is valid. And my dear students, if velocity becomes equal to velocity of light, or if velocity becomes comparable with velocity of light, then this Galilean transformation equation is never valid. Then we have to go for another transformation, which is given by Lorentz transformation. And after this video, after this lecture, we are going to understand this Lorentz transformation whenever this velocity becomes very high and this velocity of frame becomes comparable with light velocity. Then Galilean theory is not valid. Then we have to go for Lorentz transformation equation. So after this lecture, we will see that lecture. Don't worry. Now in this lecture, the velocity of frame or velocity of particles is very less. Let us say you are walking, or the car is traveling on the ground, earth, or the train is traveling, or the flight, or the any bullet train, right? All are moving with very less velocity as compared to light velocity. Light velocity is very much high as compared to other velocities, right? So I hope you understood this. So let us start this Galilean transformation equations. Now my dear students, make a heading that Galilean transformation equations. Now my dear students, for Galilean transformation equation, already we have discussed that for moving frame the velocity is very less as compared to light velocity. That's why for low velocity particle only these transformation equations are valid, and for very high velocity, whenever velocity becomes comparable with light velocity, then we have to go for another transformation which is called Lorentz transformation, and this is again one of the important topic in the syllabus. Don't worry about that. Now see, here I have written the definition. So let us read the same definition for Galilean transformation equation. See, Galilean transformation equations are those equations which relates the coordinates of particles or object to different inertial frame. Now my dear students, I will underline the keywords here, right? Relates the coordinates of particles or object to different inertial frame. Now let us understand the feel of this statement. First of all, we will understand exact real life feel of this statement, and then we will go for frame of reference, or then we will go for XYZ plane. Now let us say this is your home. Let us say this is your home, right? And in this your home, you have four members. Let us say this is one member, this is another member, this is another member, right? And he is another member. Let us name them. Let us say this is your sister, this is your mother, this is your father, and this is you, right? These are the four members. Now initially all are in room, therefore room is, or your home is one of the frame of reference, and home is never moving, right? Home is always at rest, and the persons are moving. The persons are moving outside, means home is always at rest. This home is one of the frame of reference with respect to your home where you are now. This is one of the frame of reference. Therefore this home will be your first frame of reference, because it is always at rest, and it is an inertial frame of reference, because for inertial frame of reference velocity must be constant. Now for home velocity is always constant, that is zero, right? And my dear students, initially all are in home, right? And whenever any frame of reference is constant or stationary, whenever the frame of reference is stationary or at rest, then it is called as ES. ES is for stationary, it is a ES frame. Therefore we can say your home is ES frame. Now after some time, what happens? Let us say you want to purchase something, and your father and you starts moving from your home, and your mother and your sister stays in the home. Now so my dear students, after some time, let us say your father now and you are going outside in car. Here your father is driving the car and you are sitting in the car, right? Here it is you, it is your father. Now means your two persons are going outside, means your sister and mother are still in the home only, that is in ES frame. What is the frame of reference for your sister and mother now? It is ES only, that is home, stationary, right? But my dear students, now your car is moving with some velocity, and this velocity must be constant. This velocity must be constant, and the car velocity is always less than, very less than the velocity of light, right? Therefore here Galilean transformation equations are valid. Now my dear students, now your car is moving with some constant velocity v. Now therefore, now you and your father are in moving frame of reference. Therefore this is a moving frame of reference, and moving frame of reference with constant velocity is called S dash. Therefore this is a S dash frame, right? Now I hope you are understanding this. Now my dear students, here whenever I measure any dimensions or time with respect to your home, then it is nothing but with respect to stationary frame of reference ES. And whenever I measure any displacement of any particle, or displacement or time of any particle, or as well as velocity of any particle, acceleration of any particle with respect to you, that is moving car. Now this moving car is S dash frame. Now if I measure displacement, velocity, acceleration and time with respect to this moving car, then it is with respect to this moving frame. right? All dimensions you will get with respect to this moving frame, that is with respect to S dash, right? I hope you are understanding this point, right? And my dear students, the things observed by your sister and mother who are staying in rest frame are different as compared to the things observed by you and your father, because both you are in moving frame of reference, but they are in stationary frame of reference. Means for these two persons, sister and mother, the displacement of any particle will be different, and for you the displacement and velocity of particle will be different. So what will be the acceleration, what will be the velocity, what will be the force, and what will be the time, that we will discuss. Don't worry. Now initially, see my dear students, initially you started at the same time. See, whenever time is equal to, let us say, 8 a.m. At 8 a.m. you and your father started moving from the home. Now let us say after 1 hour, what I am saying, after 1 hour, let us say you traveled 50 kilometers. You and your father traveled 50 kilometers away from your home, and after 1 hour, let us say your mom or your mother calls you and ask you what is the time in your watch. Then what you will tell? You started at 8 a.m. After 1 hour she called you. You will tell, in my watch the time is 9 a.m. And your mother will also say, in home also the time is 9 a.m. The watch or any clock in the home as well as any clock in the car will show same time after 1 hour or 2 hour or 3 hours, right? After 1 hour both clocks will show 9 a.m. After 2 hours they will show 10 a.m. Means, my dear students, very important conclusion I am telling you here. In Galilean transformation equation, time is always constant. In Galilean transformation equation, time is not a variable. Means time with respect to stationary frame t is equal to time with respect to moving frame t dash. And for moving frame, always we are using dash, and for rest frame, stationary frame, we are using only letters, not a dash. Therefore, t is equal to t dash. Understand this field. This field is very important for understanding of this Galilean transformation equation, and the rest is very simple. Now, understanding this Galilean equation is very simple. There are basically 4 equations. These 4 equations you have to write in the examination. Now, let us understand these 4 equations. I hope you have written this definition. Now, no need to write the home example. Now, in examination, you have to write the with respect to frame of reference. Now, the same I will explain here with considering XYZ frame of reference. And here I will consider one more frame which is moving with constant velocity like your car. One more frame S dash which is moving with constant velocity like your car, and after some time t it will cover some distance. Now, my dear students, let us say v is a constant velocity of, constant velocity means direction as well as magnitude is constant velocity of S dash frame, and S dash frame is moving frame, right? So, my dear students, after time t, the S dash frame, you will look here somewhere here. Let us say this is y dash, the coordinates are dash. For moving frame, coordinates will be shown with dash, x dash and z dash. Here initially the origin was O, now origin is O dash, right? And this frame is S dash frame. S dash frame means it is a moving frame. We can say it is a moving frame, and it is moving with constant velocity in x direction. This is my assumption. It is moving with constant velocity in x direction. You can assume in y direction also, you can assume in z direction also. But here, my dear students, as external force is 0, the velocity must be constant, means direction as well as magnitude must be constant. That's why we have to consider any one direction. Here I am assuming x direction. Don't worry about that, right? Means this complete frame is moving with velocity v, right? So after time t, let us say initially this S dash also starts from the origin, that is S frame. Initially when time is 0, both will at the same location, and after some time the distance between them will be, after some time the frame is moving forward with velocity v. So velocity into time is nothing but displacement. Therefore, after some time t, this displacement will be vt. The distance between two frames will be vt definitely, and as time increases, the distance between them goes on increasing, right? I hope you are understanding. Now let us consider any particle anywhere. What I am saying, any particle anywhere in the universe. Let us say this is my particle P. This is my particle P, right? And my dear students, now this particle is also moving. This particle is also moving. Now it may go in any direction. Don't worry about the direction while solving questions or while solving the field. While telling you the field, I will tell you everything. Here, first of all, we will explain the 4 equations. Don't worry about that. Now this particle P. Now let us say this particle is also moving, right? This particle is also moving. Now obviously it is moving, right? Now let us say after some time t, after same time t, the particle is at this point P. Is at this point P. Means initially the particle started from the 0. Initially the particle started from the 0, and after time it went here. Now with respect to first frame, that is S frame, the displacement of particle is x, because it is x direction displacement. With respect to first frame, stationary frame, the displacement of particle is x. This is x. For stationary frame we are using sim x, and dash is used for moving frame. But my dear students, with respect to moving frame, means S dash frame, what will be the displacement of particle P? Can I say it is x dash? Now same we have to develop relation between x and x dash. We have to develop relation between y and y dash, relation between z and z dash, and relation between t and t dash. This is called the equations of transformation equations. For any theory, the transformation equations are relation between x, y, z in both frame of reference, and relation between time in both frame of reference, right? Now I hope you are understanding. Now my dear students, here let us say one person is sitting here in the S frame at O. That means here O is a observer. This person is a observer. O is a observer in S frame, right? Therefore here I will say O is observer in S frame, that is stationary frame. And O dash, if one person is sitting at O dash, if one person is sitting at O dash, means this person is observer from this second frame, right? Therefore my dear students, here I will say O dash is observer in S dash frame, right? Very important. Now my dear students, let us understand here. For O dash, the point P location, and for O, point P location is different. Definitely the same relation we have to tell here, the same relation we are explaining here, right? Now first of all, we will find the relation for O dash observer, and if I find relations for O dash observer which is in S dash frame, the same relations are called Galilean transformation equations. So let us find. Now my dear students, always remember this O, S, Y, Z, X are used for rest frame, and dash is used for moving frame. And in each and every lecture in this relativity topic, always these both frames will come. That's why here only clear this point. Dash, if it is dash used, it is for moving frame with constant velocity, and if dash is not used, it is a rest frame. Always in this topic, so, right? I hope you are understanding. Now my dear students, for O dash observer, for O dash observer, he is lying in S dash frame, in moving frame, right? Now displacement of point P, the position of point P will be x dash, y dash, z dash, right? So for O dash observer, the equation will be, see, can I say this complete x is nothing but vt plus x dash? See, simple mathematics, complete x is nothing but vt plus x dash. Therefore can I say this x dash is x minus vt? Therefore x dash is equal to x minus vt. This is your first Galilean transformation equation. Second, see, the particle or the frame is moving along x direction. Very, very important. See my dear students, frame is moving along x direction. That means this frame is not moving along y direction with respect to previous frame, and it is also not moving in z direction with respect to stationary frame. Means this second frame, S dash frame, is at rest along y axis as well as along z axis. It is having motion only along the x axis. Therefore the y coordinate will remain same in both planes. Therefore here we can say y dash will be equal to y. Definitely it is not moving in upward direction now. it is only moving in horizontal direction, as well as it is not moving in z direction. For z axis, this s dash is also rest. For y axis, this s dash is also rest. Only along x axis it is moving. Therefore, what will be the z dash? Again, I can say the z dash will be equal to z. And how I can write these equations? Y dash is equal to y and z dash is equal to z, because y and z here no motion, we can say no motion along y and z. This is important, right? And next is, see my dear students, already I have explained. Let us say initially both frames are at same location. Let us say at time is equal to 9 a.m. At time is equal to 9 a.m. this O dash and O are at same location. If I ask you after 1 hour, what is the location of this P point? You will say it is a location here. Means from O it is x distance, and from O dash it is x dash distance. Now if time is 1 hour, means change in time is 1 hour. Therefore, what will be after 1 hour? What will be the time for this O? What will be the time for this O? It is 10 a.m. And as well as for this O dash, the time is same. The person sitting at home as well as person sitting in the car will see the same time, right? After coming home, after traveling so many distance, after coming home, the clock in the home as well as the clock in the car will show the same time. Means again here time is constant. For Galilean transformation equation, time is constant. Therefore, T dash is equal to T. Right, this is the fourth equation. So my dear students, these 4 equations are called the Galilean transformation equations. So write down here properly. So what are the 4 equations, my dear? Therefore, here I will write the first equation was, see, I am writing here properly. X dash is equal to x minus vt. This is the first equation. Y dash is equal to y. Z dash is equal to z. And T dash is equal to t. Second, third and fourth. And these 4 equations together are called Galilean transformation equation. These are Galilean, we can say Galilean transformation equation. Now I hope you understood this. Means for moving frame of reference, again I am repeating, for moving frame of reference the equations are called Galilean transformation equation. And for this stationary frame of reference, if I find the equations, then it is called inverse of Galilean transformation equation. So in examination they can ask you what are the Galilean transformation equation, then your answer is here, these 4 equations. And if they ask you what are the inverse Galilean transformation equation, then you have to find x, y, z and t. So let us find them. Therefore, for observer O observer, the O observer is nothing but in stationary frame. It is in stationary frame, right? Definitely. So my dear students, if I think about the O observer, then for O observer the displacement is x, along x direction displacement is x. And can I say x is nothing but vt plus x dash from this vt plus x dash. Therefore x is equal to vt or x dash plus vt, we can say x dash plus vt. This is the first equation. Then y will be equal to y dash. Already we have written y is equal to y dash, z is equal to z dash. Again this is the second equation. Third equation is z is equal to z dash. Third equation. And fourth equation is t is equal to t dash. This is the fourth equation. And my dear students, these 4 equations are called Galilean inverse transformation equation. These are Galilean inverse transformation equation. Right, these are Galilean inverse transformation equations. Right, now let us understand, for a rest frame, stationary frame, the displacement is more as compared to for moving frame. It is obvious. See here you can see for this stationary frame will see that the moving frame is going towards right, but the person who is sitting in the moving frame, that is observer O dash, will see that this S frame is going in left side. See, try to visualize, my dear students. Let us say here, with the help of one car example, I will explain you this phenomenon. The same phenomenon you have to equate here. The same phenomenon you must equate here. Let us say you are moving in car. Let us say this is a car, right, and the car is traveling, is moving towards right. Let us say the motion of the car is towards right. This is with velocity, right? And here one person is standing on the ground. Now for this person, the car is moving towards right. The motion of car is towards right. Yes, obvious, it is very obvious. But my dear students, let us observe the person who is sitting in the car. Now for this person who is sitting in the car, he will feel that this person who is standing on the road or who is standing near the road is moving towards left. He will feel that this person is going towards left, but in reality car is moving towards right. The same is happening here. This S frame will see that S dash frame is moving towards right, but on the other hand the observer in S dash frame, that is O dash, will see that this O or S frame is moving towards left. That's why this distance will be more. You can see here distance is increasing because it is obvious. For S dash frame particle and S dash frame velocities are in same direction, therefore the relative displacement will be lesser. And here this is rest and this is moving with some velocity. This particle P is moving with some velocity, therefore the relative displacement will be more, definitely more. And there is no motion in y direction, z direction, as well as time will be same. Therefore y coordinate, z coordinate and time coordinate will remain same, right? So my dear students, here can I say for both frame of reference the displacements are different. See, for first frame of reference displacement was x dash, and for second frame of reference displacement is, for first it is x, and for second it is x dash. Means for both frame of reference the displacements are different, means definitely velocities are different. Displacement divided by time is nothing but velocity. Displacement is different but the time is same, therefore velocities are different. Now the coordinates which are changing are called variant coordinates. Therefore here displacement and velocity are variant coordinates. And here the size of particle, for this particle, the size of particle, mass of particle, acceleration of particle, time of particle, force on the particle are not changing in both frame of reference. Therefore all these coordinates, again I will repeat, size, mass, acceleration, force, time, all these quantities are invariant, are also called invariance. So let us define, because this defining what is the Galilean invariance, this definition is very much important for competition, right? They will ask directly 2 mark or 4 mark question on this. Define Galilean invariance. So let us define what are the Galilean invariance. Now in examination they can ask you 2 mark question, that is what are Galilean invariance. Now my dear students, after Galilean transformation the quantity which do not changes is called Galilean invariance or Galilean invariant, and the quantity which changes is called variant, right? So let us understand. See, just now we have seen displacement is changing. Now as displacement is changing after transformation, then velocity is definitely changing. So my dear students, here according to Galilean transformation theory, some quantities like velocity, displacement are changed after transformation. That is, these quantities are called variant quantities. But my dear students, some quantities like acceleration, force, mass, time, size do not change after Galilean transformation. Therefore these all quantities, remember all quantities, right? Here acceleration, force, mass, time, size, all these quantities are called Galilean invariant, right? Now here what we will do, for our syllabus they can ask you question to prove that velocity is a variant and acceleration is not variant, right? Therefore here we will do velocity and acceleration transformation, and once the acceleration becomes invariant, then definitely force will become invariant. Force is nothing but mass into acceleration, and time is already we have seen invariant, right? So we will prove this acceleration, because here remember the examples, but for syllabus, for question, for your university they can ask you to find or to define velocity and acceleration transformation for Galilean invariant. So write down heading velocity and acceleration transformation. Now let us understand velocity and acceleration transformation. Now my dear students, first let us understand the basic definition of velocity that you have learned in school level. That is, velocity is nothing but rate of change of displacement. Velocity is nothing but rate of change of displacement, and rate is always with respect to time. Therefore velocity I can write dx by dt, where x is displacement because motion is in x direction only, right? Therefore rate of change of displacement with respect to time is nothing but velocity, and acceleration is nothing but acceleration is rate of change of velocity with respect to time. The rate is always with respect to time, therefore rate of change of velocity, u is velocity here. See, don't consider the frame velocity. The frame is already moving frame, but in that frame there is a particle which is moving with velocity u. In that frame there is a particle which is moving with velocity u. You can understand. Let us say you are sitting in the train. Train is already in motion, and in a train you are walking, and you are particle, right? See, my dear students, again I will repeat here. Let me write first. Acceleration is change in velocity with respect to time, rate of change of velocity. See, one frame is here. Already we have discussed. One frame is at rest. One frame is at rest, written as x, y, z, and observer is O, right? And this is called ES, which is at rest. And other frame is in motion, which is y dash, x dash, and z dash. Just now we have seen this. And observer is O dash, and the frame of reference is here S dash. And this is moving with velocity v towards right, right? And this v is a velocity of this frame in which observer is O dash. Means, my dear students, one observer is on ground. One observer is on ground. There is a train. This is a train. Right, this is a train, and train is moving with velocity v, right? And here this observer is on ground, let us say on a platform. This is a platform. Platform is always at rest, right? And this is a train which is in motion, and here in this train one particle is there who is moving with velocity u. Very interesting. This person is moving inside train. Train is already in motion, and this person can move in any direction. Therefore this is a u. U is a particle velocity. Now this u is particle velocity with respect to platform, with respect to train, and with respect to any other frame. I hope you are understanding. One is moving frame, other is a rest frame, and the particle is in motion with some velocity, and the velocity of that particle we have to find with respect to stationary frame as well as in motion frame, right? I hope you understood this point, right? Now my dear students, here I will erase this. Now with respect to C, for this rest frame and this motion frame, moving frame, we have derived the relations that is called Galilean transformation equation. So I will directly use the 4 Galilean transformation equation here. I will directly use the 4 Galilean transformation equations here. Now whatever we have seen, that is first transformation equation is, just now we have seen the same relation I am writing here. No need to again explain the same thing. X dash is equal to x minus vt, then y dash is equal to y, z dash is equal to z, and t dash is equal to t. These are the 4 equations of Galilean transformation, right? This is the first equation, second equation, third equation, fourth equation, right? Now let us understand velocity transformation first. First of all, I will do for velocity transformation, then I will do for acceleration transformation. I will prove that after velocity transformation, velocity changing. In as plane of reference changing, velocity changing. That I will prove here, right? Now my dear students, what is velocity? Velocity is nothing but a rate of change of displacement with respect to time. That is dx by dt, right? Rate of change of displacement with respect to time, dx by dt. Now from these equations, from Galilean transformation equation, therefore can I say this ux, why I am writing x? In motion along x, I am considering motion along x, right? Ux dash, if I write dash, then can I write dx dash by dt? Definitely I can write like this, right? So let us put the value of x dash. D dt of x dash is nothing but x minus vt, right? And my dear students, this velocity of frame of reference, capital V, is constant. This V is constant, already we have seen. Therefore this ux dash will be equal to, it will become dx by dt minus, now this V is constant, V dt by dt, right? And again my dear students, this dx by dt is change in displacement with respect to observer O with respect to time is nothing but ux, velocity with respect to stationary frame. Therefore here I can write ux dash is equal to ux minus v, because dt by dt is 1, right? So my dear students, from this can I say the velocity ux dash is not equal to ux, means after transformation velocity is changing, therefore velocity is called variant. Velocity transformation, this is a velocity transformation equation, this is velocity transformation equation means after transformation velocity changing, therefore we can say velocity is variant. Very interesting, right? Similarly, let us do for y and z axis. For y and z axis it will not change, but my dear students, anyhow velocity is a vector quantity. If any one coordinate changes, then we are saying that velocity is changing, don't worry about that. Now for y and z axis we have y dash is equal to y. Let us differentiate both sides with respect to time. dy dash divided by dt is equal to dy by dt, and dy dash by dt is nothing but velocity in y direction for moving plane, right? It is velocity in y direction. For reference plane is o dash, it is a reference plane is s dash, we can say, right? Dash is equal to, it is uy, that is velocity in y direction with respect to stationary frame, right? Both are same here, because there is no motion along y direction. As motion is along x direction, therefore the velocity transformation equation will change along x direction only, right? Again for z direction, we have seen z dash is equal to z, differentiate both sides, dz dash divided by dt is equal to, with respect to time we have to differentiate, because velocity will get after differentiation with respect to time only, right? And this will be change in displacement along z axis with respect to time, but it is for moving plane, therefore it is uz dash is equal to, and it is uz, right? So all these three equations, ux dash, uy dash and uz dash, all these three equations together are called velocity transformation equations. They are called velocity transformation equation. I hope you are understanding. And velocity is a variant here, because my dear students, here let me write what is velocity. Let me write these three equations first here. All three equations I will summarize here. Velocity transformation, right? Let me summarize these three equations. ux dash is equal to ux minus v. This is the first equation for the velocity transformation. Second equation is uy dash is equal to uy, and third equation is uz dash is equal to uz, right? These are the three equations, right? And my dear students, what is velocity? If I want to write velocity vector, then it is uxi plus uyj plus uzk. And what is the magnitude of velocity? It is under root of ux square plus uy square plus uz square. So my dear students, as any one coordinate change or as any one component changes, the magnitude is going to change. That means velocity is variant here. I hope you are understanding this, right? So let us understand for acceleration. Now after analysis of velocity, now let us prove that acceleration is nothing but Galilean invariance or invariant. Acceleration is not variant. Let us prove this, right? So I will do here acceleration transformation. Acceleration, write down heading acceleration transformation, right? Now my dear students, acceleration is nothing but rate of change of velocity with respect to time. Already we have seen. Now let us write the equation. Here we have first equation of velocity, ux dash is equal to ux minus v, where v is constant, other velocities are changing. Let us differentiate both sides with respect to time. Then I have to write dux dash divided by dt is equal to d dt of ux minus v, right? Therefore this will become, see what is this component, the change in velocity but in moving frame of reference with respect to time is nothing but ax dash. This is ax dash is equal to, now it will become dux divided by dt minus dv by dt, And my dear students, dv by dt will become 0 because velocity is a constant. Already we have at the start of lecture we have seen velocity is a constant for the frame, right? Therefore, and this term, we can say this term is nothing but ax, definitely. Therefore, can I say here ax dash is equal to ax? Means acceleration along x direction is invariant. Similarly, let us prove for y direction. Now let us use another equation of velocity, which is nothing but uy dash is equal to uy. Let us differentiate both sides with respect to time. Therefore, duy dash divided by dt is equal to duy divided by dt. And this will be acceleration along y direction in moving plane is equal to acceleration along y direction in stationary frame. Similarly, let us use the third equation of velocity, that is uz dash is equal to uz. Differentiate both sides with respect to time. Duz divided by dt is equal to duz divided by dt. Here dash, here first is dash. Therefore, it is become acceleration along z axis in moving frame is equal to acceleration along z axis in stationary frame. Miss, my dear students, all the three equations for the acceleration, can you observe here all the three equations for the acceleration? That from these equations, can you say the acceleration is invariant? Therefore, my dear students, here we can say the acceleration is invariant, right? Acceleration is invariant, very important. And as acceleration is invariant and the speed is very less, therefore mass is also constant. Therefore, force is equal to mass into acceleration. Mass constant, acceleration constant, force is also constant, means force is also invariant. We can say the force is also invariant, right? And as force is invariant, all the Newton's law of motion are invariant. Here all the three laws of motion, that is first law of motion, second law of motion, and third law of motion are applicable here. Means all the three laws of motion are invariant, we can say. But my dear students, at the start of lecture also I have mentioned that the velocity of this frame v is very less as compared to velocity of light. That's why, my dear students, this Galilean transformation equation or theory, this theory failed at very high velocity. When your velocity approaches towards light velocity, then this theory fails. Such as for the very high speed rockets as well as for very high speed satellites, this theory fails. And in such condition, we are using Lorentz transformation equation. Thank you, dear students. In next lecture, we will start Lorentz transformation theory.